perfectly. How's it going? How's it going, everyone?
Can't complain.
Jay, we can hear you. I don't know if your mic is on mute. So Zero. Today I brought, because I was talking with you, and this is such an important moment. I brought some support. So I have my friend, and bro, I have quite a few questions for you. First of all, thank you so much for coming. Thank you so much for being here. Okay, and giving your time. I really would like to know more about your story. So, can you tell us, going from the start, how did you get into development?
Yeah. First off, I gotta give a shout out to the sweet profile picture that JT's got.
Yeah,
Hey, appreciate it. It was one of those waifu gens from Nemu. Used to be with the DeFi Llama team. It's pretty cool.
Dig that, as well as your Twitter profile picture. Nice little discreet.
Yeah, I almost feel like I feel like a zero age LARP, because it's like the same shape, just like a different color. But
true.
it's pretty sweet, man. I like that concept of like declaring agency over time over your NFT. That was a pretty cool idea.
Yeah, I can't hold claim to an abstract rectangular shape, so those are public goods. Glad that you're rocking it.
And they're public goods, but everybody knows the green rectangle.
Yeah.
Well, yeah, my origin story is a touch enigmatic by design. I obviously operate under a pseudonym, but my first foray into crypto, aside from as a largely passive observer, spectator, speculator, was in 2017. Was I began by creating a decentralized club, and this sort of predates the wave of Bored Ape Yacht Club and other NFTs that sort of served that role. The club was called the Cyber, and I sent a bunch of uh, access codes out to various people in the space at the time. It was much smaller then than it is now. And in order to gain entry into the club, you had to solve a series of puzzles, right? Similar to capture the flag style stuff you see a lot of today with Curta and other very cool capture the flag initiatives, things like that. And after that, Open Zeppelin reached out to me and wanted me to contribute to Ethernaut. That led to doing work with Open Zeppelin, building out a protocol for what was at the time seen as a promising direction, namely security tokens. No spoiler alert, those did not take off, and probably for the best. From there, I started doing more low level applied research, got in deep into all the wacky stuff that was enabled by Create 2, which, when it first broke on the scene, I don't think that a lot of people had really reasoned through the implications of being able to deploy and redeploy contracts to the same accounts. So that led to work on metamorphic contracts, different patterns for upgradability, and culminated in a project called Homework, which was an NFT or is an NFT for parking an address and saying, all right, I can deploy arbitrary code to this account, go mine a salt for it, and then you have an NFT that gives you the right to deploy to that account. From there, I joined Dharma, which was a smart wallet. at the time when I joined, it was actually pivoting from a lending protocol. Dharma was the original uh, compound analog, but um, every uh, party you had to basically match lenders and borrowers. Then, of course, Compound and others like Aave came along and had single-sided markets. And Dharma was having a bit of a what do we do next? And I came on board and made the case to build on top of these other protocols, Compound, they eventually Uniswap, and we built out a whole framework for using smart wallets, which at the time did not see very much usage. I think 4337 is really going to change that, I hope, and L2s. But we built out a smart wallet for making it really easy to connect a bank account and immediately start plugging into this DeFi ecosystem. And that was a great time. We were acquired a year and change ago by OpenSea, and I've been at OpenSea since. Built out the Seaport protocol with the help of many talented developers, Dylan Keller, Transmissions, Emo ETH, James, and a number of other really talented contributors. So now Seaport has been through a number of versions. We're on version 1.5, which is sort of the culmination of a lot of learnings in the wild on how people are using Seaport. Very excited about this next phase. We've settled into a pretty robust Seaport implementation. And now this next era is one where using Seaport apps or contract orders, all of a sudden we should be able to natively extend the protocol in really novel ways. And I'm very excited to see what people start coming up with. And Seaport is already being utilized by a wide variety of different NFT marketplaces for buying and selling NFTs, and even other protocols that aren't specifically tailored to NFT marketplaces, but have found it a generic and flexible enough framework to where you can really just express intents, as the kids say these days, and buy and sell arbitrary tokens.
Regarding Seaport, what was the process in building and testing the software to keep it consistent? I know you guys have different versions and keep on iterating over it, but you gotta have some sort of method because you guys have produced such quality.
So our philosophy with Seaport at the time when we first proposed it, it was really targeted at addressing the weaknesses and shortcomings in the Wyvern protocol, which was being utilized at the time. And Wyvern has a lot of great things about it. Very flexible and basically could be adapted to buying and selling NFTs, even though the protocol predates NFTs, right? That tells you something. However, it was not designed with efficiency in mind. So it was a controversial decision to, right out of the gates with Seaport, to release something that utilizes so much assembly code, right? And simultaneously trying to tamp down on the most egregious threat vectors and issues with Wyvern because of its expressivity meant you could do things that were you could trick people into signing payloads that would irrevocably reject them from the system or sweep all of their NFTs at once, even retroactively. There were a number of things that were just strict no-nos. So we made the opinionated call, okay, let's focus on native tokens, ERC20 tokens, ERC721, ERC1155. But aside from that, we really leaned into flexibility on, well, you should be able to offer any number of tokens. You should be able to request any variety of tokens back as consideration. And it should be very fast, because at the time, the Wyvern protocol was just chewing through the network capacity. And once you hit scale, it becomes really important to optimize for what gas you're using and build a primitive that you can then add complexity on top, right? We leverage this zone concept pretty extensively at this point. But if you want to just go low level, you should be able to buy and sell NFTs with as little overhead as possible while still maintaining this degree of being able to list off chain and having the basic safety checks in place to where you don't have to necessarily trust the buyer or the seller. It's all verifiable, and leaning into reference implementations. The second piece is, of course, audits and code competitions. There's no substitute to getting as many eyes as possible on your project. Obviously, having something that people are interested in helps a lot. If it's just another AMM fork or something, and you're not going to get as many eyes on it as you would if you're introducing something that's novel. I also think that the fact that we leaned into really permissive open source MIT licensed code makes it, and that the contracts themselves don't have any notion of protocol owner or fee or upgrade mechanic, really makes it more of a hyperstructure. So I think that got more people excited about looking through the code and contributing and helping to review it. And we also ran a $1 million code arena competition.
Wow.
So that was, and it turned up 4 high and medium severity issues on Seaport 1.0.
You got surprised by that? A bit,
this
right?
was coming. We had just wrapped on an audit with Trail of Bits, who are, I don't have to tell you guys, they're some of the best in the game, and had a fully comprehensive test suite. And there's just no substitute for just the wisdom of the crowd. And just having your code in an open source repo is not enough, right? If there's some incentive and skin in the game to actually poking around, then you're going to get the best of the best. Through that competition, we also discovered Spearbit. I mean, they were on our map, and I knew many of the initial founding auditors are core Solidity devs, and that they definitely had pedigree, but their showing in the Code Arena competition, it almost served like a recruiting tool, where some of the people who performed best in the Code Arena competition, and including Spearbit, became regulars and have audited Seedrop, which is our platform for minting NFTs, primaries, and other contracts, and as well as other Seaport versions. So that's the second piece. And that's a whole conversation topic of its own, is how do you find the right auditors, the right fit? What's a fair price? What's the right model, or do you do bounties or code competitions or formal traditional audits? But it's a really important component of developing really secure systems, right?
What is the biggest consideration you make when adding features to Seaport? What kind of filtering or funneling process something goes through to make sure that that's actually valid?
Yeah. So that gets into the third piece of our process and structure, which is listening to the community. Particularly, I'm particularly interested in the community that's building on top of Seaport. It's using Seaport. What are the pain points? What are the areas where it's lacking? What are the alternative protocols that are doing things better or more efficiently? And how can we incorporate some of those ideas into future versions of Seaport? This jump from 1.1 to 1.2 was pretty much the summation of that whole process, building up a Seaport working group of developers that were using Seaport and figuring out what was and wasn't working. Then, of course, there is also just listening to your users. The one of the key components to the Blur marketplace when they initially launched is that they supported bulk signatures. You could list a bunch of things at once and only sign for a single payload. And that's one prominent example of, all right, now users are demanding this new feature, so we've really got to figure out a way to safely support it. I should mention that the way that Seaport handles bulk signatures is objectively superior to many of the other initial experiments in this, where you're pretty much just signing an opaque 32 byte payload. You have no idea what you're actually signing for. So I'm pretty psyched about where we landed with that, and it has been something that people use pretty extensively. So it really boils down to having an iterative process in tandem with the community, where we are still deliberate, right? It's not just throwing in the kitchen sink. It is quite tricky actually to add new functionality to Seaport, because it's built up as opinion in a very opinionated, optimized, low-level way, and you can't just shim things in part because the contract is already it's been golfed to the extreme to where you don't have much headroom in terms of the contract size limit unless you're going to break it up into multiple contracts and all of that. But also just because the flow from the time you enter the contract to the time it returns is pretty tightly constrained, right? But the things that are worth including, that there's enough demand for, they make their way in. And I do think that there's an elegance to the concept of zones and now Seaport apps, where a lot of these feature requests you can just sort of punt to, well, you can achieve this with a zone, like just use a zone, and you don't have to modify Seaport. You can just opt into using this particular zone that buys you some new functionality. There's definitely a backlog of things that we want to include in the next version as well, but the current version, it has the benefit of these primitives that you can build on and enhance the native functionality, which we are both internally at OpenSea as well as more broadly in the community all grinding on now. And working on developing common standards for how do you discover various Seaport apps and zones? How do you interface with them in a consistent way so it's not you're not siloing liquidity um, or pigeonholing into a specific marketplace or even use case. A really good example of that is we have this new signed zone standard, which gives you a way to insert like a server side check on liquidity. And that can be applied to a number of different things. We're applying it at OpenSea to bids, offers, where you can put out a collection level bid and not end up buying compromised items. Or you can create a listing and then decide you want to cancel it. And rather than submitting it on chain, you can just request that we stop providing signatures. And so thereby, as long as we uphold our end of the bargain, you have gaseous cancellations. So that's like one potential use case, but we're also using it in C drop, for instance, the exact same standard where you have a common structure and format and means for interaction with the C drop contracts and can do signature based allow lists and things like that. So that's just one example. There's a number of really interesting proposals for different standards and implementations that are starting to emerge for all kinds of stuff.
You know, Zero, several times I've been told your team is amazing and probably the best team in smart contracts. So I would like to know first how big your team is today, okay? How does one can get a job at OpenSea? And if you can, tell us the base salary for a mid-level engineer.
So I'm quite proud of the team that we've assembled. It's a little bit of an unconventional structure because we have a combination of full-time internal we call it the ecosystem team. And within the ecosystem team, there are 4 of us that are exclusively focused on smart contract development. But then we also have a number of contractors. And our contractors are absolutely top notch and tend to focus on one area where they really excel. A lot of the best smart contract developers prefer a degree of autonomy and flexibility and don't want to be tied down to just one thing or one organization. And it kind of makes more sense for them to be able to come in, grind on a particular thing. Like Dylan Keller, great example. He works as a consultant. And when it's time to optimize Seaport, right? We've got the reference stuff done. We've got the whole set of requirements for this or that. Then it's like, all right, let's shave off some contract size so we get this under the limit. Let's optimize the daylights out of this by building custom encoders and decoders. Then he comes in and helps deliver on that, and then he's off to the next thing. I think that's a really cool model for on both sides
Really
of the equation.
flexible.
Another very good example of that is HorseFacts, who I'm sure many of you are familiar with. He's an absolute expert when it comes to testing. It's a rare thing for people to be passionate about testing, but testing is literally 90% of smart contract development. It's totally critical. You spend a fraction of the time actually authoring contracts as you do writing tests for those contracts, or at least you should if you're doing your job correctly. But most people kind of hold their nose and write the tests and call it a day once they feel like they've got enough. We knew that we needed to double down on testing for the latest version of Seaport. And Horsefax came in as a consultant, but was working day in, day out for months on a new, really sweet testing framework that we have. Internally, we codenamed it the moat test, the mother of all tests, the single test, just one endpoint that
Wow.
covers almost the entirety of Seaport if you run code coverage, but tests every combination of the different number of items on each side, different number of orders, restricted versus non-restricted, contract orders, different signature schemes and types, and any lever or knob you can pull or twist or whatever, they all got thrown into this single fuzz test. And then we just pointed our infra at it and ran hundreds of millions of fuzz runs to ensure that we were testing all of these different combinatorial paths. So that's a high level. There's definitely a challenge in integrating a team like our ecosystem team, which is so focused on writing smart contracts. There's a challenge in integrating that into a broader organization like OpenSea, where there are a lot of balls in the air and front end and trust and safety and infrastructure, more traditional Web 2 stuff, and then all of the different just pieces of the puzzle that go into running a business. And it's a very hard sell to be like, well, we need 2 or 3 more people full time that are just going to be writing tests, right? It's easier to hire full time for big projects or initiatives that have concrete deliverables.
Yeah.
But it's always it's an evolving thing, and anyone that, like, we can make room for the best and brightest, particularly if they've got some unique skill set or vision. And the first place that we look is there's a very solid pool of people that are already building on Seaport and making really cool stuff, or finding optimizations or potential bugs, or you name it, right? That's the top of the short list.
That's so cool, bro. You know, it's just amazing. So I wanted to talk a little bit because I have, Jtriley, the Gachi, GM Hacker here. I wanted to talk a little bit about optimizations and bytecode overall. Today, there's a notion that we're sacrificing readability to achieve, a greater level of gas optimization. In your view, what is the right balance in there regarding having a really optimized contract but also being readable, or is that even important?
It totally depends on what the contract is or what the application is. Even within Seaport, there are a couple of contracts that are at the core of Seaport. You've got the main Seaport contract, right? And that is, of course, very optimized. But then Seaport has this notion of conduit, right? A conduit is it's the way that we handle the design space of token approvals and being able to sort of choose your own trust model for how you want to handle adding or migrating to new versions of Seaport. And if you look at there's a conduit controller that all compatible conduits, they all have the exact same implementation. And all they do is just, you can add and remove channels from the conduit. Channels are things like Seaport versions or we have a transfer helper for just batch transferring NFTs that are. So Seaport 1.5 is on our conduit. There are others that have deployed conduits to a bunch of different chains. But they all do the exact same thing. They just, if there's an open channel, it tells it to move tokens, and it'll move the tokens. But if you look at the conduit itself, it's also hyper optimized. But then you have the conduit controller, which is this factory that deploys the conduits. It's the sole input to Seaport is like, what's the conduit controller? And if you look at the conduit controller, it has almost no optimization. It's written in high level Solidity, no assembly. I don't think it has any assembly. It prioritizes readability. And the reason for that is, how often are you going to be deploying new conduits? And if you are, ostensibly, you don't care as much about shaving off a little bit of gas. You want to be sure that it's as bulletproof and secure as possible. So that's not to say you don't want everything to be secure, but it really does matter if you are going to be seeing the kind of transaction volume that you do on a marketplace like Seaport, where it racks up a lot of transactions. And it's not just that, let's say it costs twice as much to do a trade. If you are regularly consuming 5-10% of block space on a contract, that trickles through to the gas price on the entire network, and you can even get into a kind of death spiral where, because everyone is paying so much to execute these time sensitive operations, then you have to get into these bidding wars, right? Whereas if you manage capacity, it makes more sense. So that's the fundamental thing, is what kind of traffic is your contract actually going to have? Optimization on
Interesting.
core governance stuff does not make any sense. Or stuff that's only utilized once in a while, changing owners of contracts, things like that. No way. More broadly, though, let's just say that I have a contract that I do think is going to see significant volume, right? Transaction volume. I still don't think it's as cut and dry as, do you optimize for readability or efficiency? There's also this piece that's like, how can you have both? And if you read the Seaport contracts, we've really tried our absolute best to make the assembly as readable as possible. There's the only reason that high level Solidity is considered more readable, really, is that there's more familiarity with it. There's more documentation around how it works. There's examples all over the place. And so everyone's kind of, if you've been working in this space for a while, you're familiar with what Solidity looks like. But under the hood, if you understand the way that the Ethereum virtual machine works, seeing things laid out in assembly actually makes the underlying processes more legible. Like, I would prefer to read really well commented assembly over Solidity at times, because you don't really know what Solidity is doing without going and digging through the documentation and be like, oh yeah, so when I have a nested storage mapping that's like pointing to a struct, how is that I don't know. But if I can just see the assembly, it's all laid out for it, and any issue or bug there or problem, it's going to stick out. But we also use conventions like every constant is named, and so you don't have to be like, oh, what's 0x60 again? You can be like, oh, it's just, this is the 0 slot, right? And refer to it as such. So there's a lot of work that went into making that readable. And every single line of code is commented, or just about every single line of code is commented in Seaport.
Really cool. I don't know if Jay has a question. Jay?
Yeah, so for one, I definitely want to point out the like naming of these like magic numbers has definitely been like hugely helpful, and honestly, I've kind of adopted it in a lot of the assembly that I write now too, because it's for somebody that has context, right, that understands like the Solc compiler enough to know like what mload 0x40 means, like that's fine, but for a lot of people it's not, and I also agree in a way that like sometimes I find assembly like more clear than Solidity, because yeah, there's a lot of like unexpected behavior and a lot of like really strange things that are like either not documented or not documented very well. And then like so Dylan has actually pointed out like a ton of just like these wild things that happen in the Solc compiler that you don't really know about unless you really like dig for it, right? So just out of curiosity, because this is something that that I've personally been trying to like grapple with, is like just maybe from a high level, if you could have a brand new language to write, let's say like a Seaport v2 in, right? Like what are some of the key features there, and like what are like kind of what does that look like from a high level? Like what would you be looking for in something like that?
Oh yeah, I've jammed with Dylan quite a bit on this, and I think that it's actually not that far out of reach. The key thing I think is, now that we have this really solid intermediate representation target, like if you can write a higher level language that's syntactically similar to Solidity, so you have that familiarity that still compiles down to Yule, so you can leverage the tool chain and pipeline there and still back out to something that's a nice intermediate representation. Then what you really need, you need the ability to punch through to either raw assembly, or like you should be able to, aside from maybe directly accessing the stack like you would in Huff, I think there are some abstractions that if you're going to use that IR target, you're kind of stuck with, but they're it's not the heavy hitter stuff. But being able to insert your own specific inline assembly without the overly opinionated stuff, you could keep so much of the Solidity syntax and just take a different approach to encoding and decoding is probably the biggest thing, right? Like that. And I also think that call data representation, there's so much fertile ground for exploration on different ABI schemes, right? I mean, especially in an L2 context, being able to do call data compression in a way that's not complete gobbledygook, there's a lot of promise there. Yeah.
Yeah, it's the encoding thing is really really interesting. Even even on L1, I never realized it until Dylan pointed it out with the ABI leader tool. I think that was used a bit in Seaport for the like custom encoders and decoders, right? But yeah, I never realized that call data is actually pretty expensive on L1. It's not as cheap as it might seem, and of course on L2 it's like near prohibitive, right? But yeah, I agree. Like I'd love to see more ABI encoding schemes. Things that aren't just the way that Solc does it. I think it's really tricky. With things like ERCs becoming a bit, becoming pretty entrenched. There's kind of like limits to what we can do with that. Like for example, like if you take, let's see, standard transfer from in an ERC20, right? Like everything is standardized there, and everybody kind of runs with that in particular. Oh, 1 second. I think. Oh, looks like GM hack. He's got a drop. Oh, he's gone. Rip. But yeah. Anyway, so because there is like a sort of standard, like a standardization around it, because so many people use it, like it's really hard to like break out of that, right? So it's almost like you need these sort of like external, like almost routers, like periphery, right, to handle like getting that tightly packed call data on chain, and then dealing with it from there. I'm actually curious, like what that would look like for L2s, because so much of that cost is encoding. But what do you think about? I don't know, like how do you like deal with
Yeah.
compatibility?
Yeah. It definitely is a lot cheaper if you can go through some kind of transformer and just adapt compressed call data into something that's standard compliant. I would actually advocate that much of like the ossification around ERC standards and things like that, that's not really where the overhead is coming from. It's coming from these huge beefy calls that take, like, let's just look at Seaport. It takes an array of structs, each of which contains their own arrays of structs inside of it. It's just absurdly inefficient from a call data standard representation. Not to mention the default ABI encoding doesn't support type units. It doesn't support a way to dynamically say like, okay, based on let's stick with Seaport. Based on the item, you shouldn't need to represent it with, right now, if I'm supplying a native token as an item, there's a lot of fields that are empty. And Seaport even has to check that those fields are empty so that it protects against spoofing and things like that. All of that is just waste. And if you can represent things in a more compact way where you're actually saying, well, it's actually type 0 or type 1 or whatever for this item, so we can represent it with this much more compact scheme. Yeah, there's a lot of exciting stuff to explore there. And I'm not overly concerned with even breaking with convention on the ABI stuff, because you can still always use a transformer. But it seems better to have that for the reverse case rather than being the default case of that you transform going in with a compact scheme and then unpack it so you can call your actual contract. How much cooler if the actual contract takes the compact scheme, and if you don't know how to speak that language, you can call the transformer with the verbose version and it'll pack it.
Wow, that's a really cool idea. Dagashi, did you have something?
Yeah, I'm just gonna chime in. Like, if you had cross compatibility issues, it might even be a good idea to just have, like a GitHub repo explaining how to interact with these, low-level functions with custom call data inputs. And that would also just like educate a lot of people, because a lot of people are going to be using the protocol. And they might even just have like a copy paste for each function. They just put in like the assembly block, inline assembly into their Solidity, in place of just like a function call. And just like some comments. And I think that would actually just do the trick easily. It could be like, that would solve like a massive chunk of like headaches for these devs that only work with Solidity. You can build your contract in half, or inline assembly, whatever you want to do, and then have examples and documentation that just makes it so much easier to integrate. But that's just like my little 2 cents.
You hit on a really interesting point that we've talked about quite a bit, and that is a platform like Seaport is actually pretty fantastic for breaking through that chicken and egg kind of barrier on any kind of new language or feature thing. Like, it would be a fantastic staging ground for a new language, for instance. or a new call data ABI scheme. We simultaneously want it to be approachable and easy to use, but efficiency really is king. And for the end user, they do not really care whether or not it's ABI compliant. They care that the top line gas number that they're paying is lower. And you can even make things safer, right? By avoiding pitfalls around the current ABI stuff. Like a good example of that is when we go into basic, like fulfill basic order, we enforce a very specific, stricter version of the ABI encoding so that we can pull directly from a given region of call data and just plop it into a specific region of memory. It's not the way that it generally works. You can construct non-standard ABI requests where the call data pointers are pointing to unconventional regions or duplicate regions or things like that. And now this is, especially if you're dealing with assembly, that's something that you have to design for and check. And so the point being, you actually can make things safer like that. But we've been leaning into this pattern of on-chain libraries as well, that where the idea is that you're not actually calling the libraries as part of your transactions, but you're leveraging the libraries because anywhere that Seaport is available or your protocol is available, the one standard, no matter what language people are building things to target it against or whatever, the one standard is that if they're interacting with your contract, then they can interact with the blockchain that your contract is on. And so having libraries that live alongside your contract that you can use to make it easier to interact with your protocol is sort of a no-brainer and gives a really solid reference for how to perform certain actions or steps. And one could envision a really similar procedure there for a number of these, like call data or ABI themed innovations, similar to like a multi-call contract, right? Where you hit that and you know that it's going to be there and you can just call it and it will go and get all the state you need. You could have something similar where you just call it and you give it the types of like the function signatures and arguments that you're formatting for, and then all the data, and give you back the compact representation in some new ABI encoding scheme, that kind of thing.
Really cool, really cool. You guys have any more questions? Because we cannot be taking so much time from Zero. Anyone here in the chat want to write something? Jay, Degati, any last questions? Zero. Thank you. Go on, Degati.
Oh, sorry to break. But yeah, I don't know if you've already talked about this or not, but I guess how did you even get into all of this with Seaport and doing low-level contracts for basically like these big names?
Yeah, we talked a little bit about where I got started in blockchain development. Some other tidbits about like how Seaport came to be. I've been trying to convince projects to go with assembly code for years, and up until Seaport, really, every time I'd be like, hey, look, so we can do the Dharma Smart Wallet, for instance, we can do it in this raw EVM bytecode where every wallet is only 53 bytes to deploy, and like it's feature compatible with the reference, or we can just do this reference version and it'll be easier to audit and it'll be twice as expensive. And every time it was always, this seems too risky. And it wasn't, I wouldn't say, it was probably once we started seeing the gas regime where pre 1150 or pre 1559, I'm sure some of you remember gas would get up to like the thousands. Particularly, the number one thing that would cause these gas spikes were NFT drops or really hot initial secondary sales. And that's OpenSea's core thing, is that they were, especially before there were other generalized NFT marketplaces, every other marketplace was like curated, right? You'd buy or sell NFTs that were curated from them and dropped through them, whereas OpenSea would just instantly index any new NFT and make it available to buy or sell, assuming it met all the sort of trust and safety considerations. But so they were just getting hammered on gas. Users were paying so much in gas that I think that was the first, it was like the light bulb moment where people are like, okay, you know what? Maybe Zero's not insane and completely unhinged to keep proposing these contracts with assembly. And I feel like it kind of, the combination of people waking up to the gas does matter, even when you're not currently in a really high gas regime, it still matters. And also just the ecosystem maturing to a point where there is a lot of competitive pressure to do things in a more optimized way. That was it sort of broke the dam, and now I think there's so much cool stuff, and the whole subculture around optimizing contracts. It's sort of like the entry point for a number of smart contract developers where they want to learn more about how the EVM works and golf contracts, which is fun. It was very, very niche back in 2017. There were probably like 10 people that could write
Still niche,
something
right?
with low level. Yeah.
So I actually, out of curiosity on this, curious what your thoughts are. Like, so right now, obviously, it's we could consider Ethereum a sort of like resource constrained environment, right? Like this, it's very limited compute, very limited like what we can do with it, right? And so there is like this huge incentive to optimize. But do you think, is that a product of just the fact that we haven't scaled the technology very much yet, or do you think as long as interacting with the machine costs some amount of money, then it'll basically always be to some degree a resource constrained environment? Like basically what I'm saying is like, will optimization be important as scaling improves?
Yeah. There are absolutely environments even today where it's just clear that resource constraints are not the primary bottleneck. But in a system where you have to, you want it to be permissionless, then and high security, you need constraints, or else you'll just get DOSed to death, right? Like the spam will be out of control. The noise to signal is just really unbearable. So I think even on L2s, it's like the thing where if you build more freeway lanes, then you just have more cars driving on the roads. It still matters to have a car that gets good gas mileage. And yeah, you can have more meaningful activity without having to constantly be running up against these bottlenecks. I don't know. It will be really fascinating to see if L2s are or L3s or whatever it takes is truly able to just unlock a world where, yeah, screw it, just deploy Python code or something and run it on the blockchain, doesn't matter. And yeah, there's certainly remains to be seen where we land on that, but for the time being, people value L1 block space, and it's not like all the prominent NFTs are going anywhere yet. They're all on Ethereum or other L1s for the most part. I expect that to start to change. We're already seeing a pretty vibrant community of NFT creators and collectors on Arbitrum and Optimism.
And now
Be really exciting to
Bitcoin.
see what happens on base. Yeah. And now Bitcoin. Oh yeah, the ordinals piece is pretty fascinating.
What is your view on that?
My view on ordinals?
Yeah, on the whole
Well,
Bitcoin assets, you know?
my personally, I love truly on-chain NFTs. And I think that for a certain category of on-chain, Bitcoin ordinals are actually pretty solid. Like, and I think they refer to them as digital artifacts. And I think that's a pretty good nomenclature. They're not composable in any meaningful sense of the word. The metadata is not actually accessible from an on-chain context. And if all you really care about is archival, then I think that's fine. It doesn't matter. But what I think is most exciting about NFTs is when you have dynamic on-chain metadata that is accessible from within that chain in a programmatic way, right? I think a lot of people saw the promise for that in the loot era, right? That all of a sudden you have this item where you can plug in and build with other things. Now, it was sort of ahead of its time in certain aspects, but I think as we start to see more dynamic traits be moving on chain, representing things in the real world, it's going to become really, really cool to have that capability, right? I mean, let's take redeemables. This is something that Devin has talked about, OpenSea's CEO, that redeemables are a really interesting use case for NFTs, where you can have a property, a trait on an NFT that's like, has this been redeemed for the hoodie or whatever, the concert ticket? And if you can buy or sell that NFT based on its trait, right? You have a zone, the Seaport zone, that checks the trait. And if the concert ticket hasn't been redeemed or the hoodie hasn't been redeemed, then you're interested in buying it. Otherwise, you're not really interested in buying it. How do you do that in a trustless way with ordinals? You just can't. It's a whole different thing. So I think you have to go beyond just putting the metadata into a blob. You have to make that blob accessible somehow. And I think that L2s are the right scalable approach for doing that and still being able to prove aspects of, okay, this NFT has this underlying property, right? I mean, I'm sure that people here have seen like ETH inscriptions, same premise.
Yeah, I was about to talk about
right? So if you're just trying to put something on chain, you can do that and say, okay, here's the call data for it, but it's not really inheriting the the most exciting and innovative components of what makes the medium really promising in my perspective. So I think that there is a place for things like Bitcoin ordinals. If what you're looking to do is to inscribe something in a way that it's going to be highly likely that for the foreseeable future, that metadata can be recovered.
Nice.
It's archived. Then I think it's cool for that. But I don't know if there's really as much staying power there. Another thing that I think is really, really cool about NFTs is that you can have verifiable randomness and do generative art where it's not just the creator creating some generative framework for art and then trying it 10,000 times and picking their 10 favorites, but it's actually the algorithm is leveraging randomness from the underlying blockchain that it's on, right? And I don't see a path to really supporting true generative art on ordinals, for instance. Maybe there's some clever workaround, but I think it's much more just, oh, here's a bunch of data, throw it at in the witness, right?
Interesting.
So yeah, that's my take.
Awesome. Zero.
Our current focus is on EVM chains and also really interested in some of the ZK chains as well, ZK EVMs that have slightly different frameworks and that kind of thing. Developing on Bitcoin is just, I don't know how many of you have spent much time building on top of Bitcoin, but it's pretty painful.
I see, bro. I see. Okay. Guys, anything else? I think it was pretty good.
Yeah, my lines are open anytime that you guys have, if you're building on Seaport, I encourage you to come join the Seaport working group. Reach out to me anytime if you have questions or ideas. And thanks for taking the time. It's good to chat.
Thank you so much for being here, Zero, and talk to you guys later. Bye bye.